Hello everybody, thank you all for joining this webinar, the expert session. We're broadcasting live from our headquarters in the Netherlands with Leapfrog headquarters in Alphen aan Rijn. My name is Frank Valkenburg and I'm the account manager for Leapfrog. Today I will give you a short introduction about Leapfrog and I'm going to tell you the advantages of the Creator HS, high speed. After my story, then David will start presenting. He's our engineer and he will give you tips and tricks on how to use your machine and how to use your software. Now we have a 1 minute delay with broadcasting. Therefore we choose to have a chat session where you can live chat with one of our support members, who is Mirja Old. So if you have any questions, just ask him. If he doesn't know the answer, we will get back with you later, or if it takes more time to give an answer. Now let me start with the program. The program for today, we will also switch, by the way, in between sheets. So we do partly in front of the webcam we will present and partly in front of the PowerPoint sheets, because sometimes we need to zoom in or have more detail on a certain aspect and we can present it better through PowerPoint sheets. Now today's program, as mentioned before, I will start with a short introduction. Then David will take over and I will get back to you at the end. Now, first of all, for some of you who don't know Leapfrog, we started in 2012, May 2012, within our mother company, AV Flexologic. Now, AV Flexologic is an engineering company that exists already for 40 years. And a couple of years ago, they needed a 3D printer. They needed a 3D printer to make customized parts, where they weren't limited with designer freedom, and they needed to make prototypes and they needed to make them fast. So a 3D printer could help them with this. So they started purchasing a 3D print kit, which they first had to build themselves. But they discovered that building this 3D print kit took a very long time, and it was a real hazard to operate the machine. So they said, well, we're going to build our own 3D printer. With all the means and materials we have at this company, we will start building our own 3D printer, and that's what they did. So they built the Creator, which was our first model, and they took it to a trade show to show the level of innovation of AV Flexologic. Now it turned out that there was a lot of interest in this machine, actually in the Creator, in the 3D printer, and this is when Leapfrog started. And as of today, we're a company with around 70 people working at Leapfrog. And we produce and sell over 100 printers per week. Now, this is our new model. It's the Creator HS. I'm going to talk about the advantages of the Creator HS. For those of you who have a Creator 2014 model, it might be worth to take a look at it. Like laptops or like computers, 3D printers are developing very fast. So every year there will be a new model which is faster and which is more accurate. Now with the Creator HS, we maintain the same very stable design. So we have ball bearing spindles in triangular form to make sure that we have a large bed. You can lean on the printer and it won't deform. But what we made new with the printer, with the Creator 2014, we had the engines mounted on top of the extruder head. Now we have the engines mounted on the base. So the extruder head is a lot lighter, so it can move up to 3 to 4 or to even 5 times quicker than the Creator 2014 model. Also, it's a lot handier to operate the machine. You can see in front, of course, the USB stick. You don't have to hook it up to your computer anymore. Just insert your USB stick and select your G-code. Now, if we look at the back of the machine, it's also quite interesting. We see 2 levers. Now, this is a patented option of Leapfrog. What you can do is you can pull the driver gear open so that a gap exists in between the driver gear where you can easily flow through the filament. So you don't have to peel with your filament in between the driver gear anymore. You can also release or increase tension on the driver gear. Now another handy tool, there are 3 knobs underneath the bed in order to easily calibrate the bed. David is going to explain later on how it works. Also, the machine is a lot more accurate because we have new software installed in the machine, and also the new development of hardware changes make sure that the X, Y, and Z axis cooperate a lot smoother. Last, you can see on this object that the HS is able to make very large objects, very smooth objects as well. Okay, well, thank you all. This was my part. Now David is going to present to you how to use the machine.
Okay, thank you, Frank. My name is David van den Bergen. I'm engineer at Leapfrog, and I'm going to tell you a little bit about the Creator HS and on how to get successful prints or more advanced print on the 3D printer. You have to excuse me if I look to my side every once in a while. That's where my cheat sheets are, because it's a pretty long story and I cannot remember everything at once. So Frank, if you would start the first sheet, please. Getting the best results for your printer, the first thing what you need to know is material type. Choose the material that suits the function. If you're going to print something functional, or if you're going to print something that's only visual. So for visual you can use PLA, but you can also use ABS if you have a lot of overhang, because it prints nice overhangs. And we also have an option that you can print flexible material. If you go to the website of Leapfrog, we will soon have a small attachment available that goes inside the drive gear, and that way it's possible to print with flexible materials, and you will be able to get flexible objects out of your printer. That will soon be available on the website as well. Next, I want to talk about material quality. You need to get the best material quality you can get. You can get really cheap filaments anywhere in the world. You can nowadays order them through the internet. But the problem is your print is only going to be as good as your material. If you have a low-grade material, your print is going to be a low grade. At Leapfrog, we strive at finding the best material, and that's what we sell. It's the best grade material that we have. If you have cheap PLA, for instance, after a while, the PLA will just snap. It will become brittle, and you cannot print with this PLA. You can try to print with it, but of course your prints are going to look very bad. So make sure that you have the best filament that's out there, because if you have low-grade filaments, your prints are going to be low-grade as well. For the next slide, please, Frank. The next thing is, please work clean. As you start printing, clean your machine. Wipe your nozzles with a cloth, so no residue is still stuck on there. If you try to make a nice red print, and you have previously been printing black, and it's still stuck to your nozzles, the black can come into your print and you have really black spots inside it. So wipe your nozzles with a cloth. Also, use a fresh, clean bed, a fresh print sticker without any damage, and purge your hot ends. If you still have ABS or PLA stuck in your hot end while you're trying to print something else, make sure that you purge it and make sure that your hot ends are absolutely clean. The next thing is calibration. Make sure the printer is doing what you want. You have to calibrate it. Get to know your printer and your materials. Some materials print others differently than other materials, so you might adjust the extrusion multiplier. And the next point is, make sure everything is leveled and calibrated. I will briefly show you how to calibrate your printer without hooking it up to a PC, because that has been a question we have been getting a lot. With our standalone version, through the menu, you can set the printer to home, and the printer will home to its origin. The only problem is that after homing, the bed will drop down a little. That's because if you heat up the extruders will be touching your bed, and that way you can either damage your bed, or heating up doesn't work as properly because the heat is going into your bed. So now it drops down and there's a little gap, so make sure that is not touching your nozzles. Only problem is that now calibration is hard. Well, there's a little trick I'm going to show you. As soon as you homed, move your head from the printer gently backwards, and on the side, inside the printer, there's a small Z sensor. And on that Z sensor, there's a tiny little LED. You can move the timing belt on the bottom of the Z drive, and you can move your bed upwards until the little LED light comes on. And you have to find that exact switching point where the LED goes on or off. And then you found the level at which the bed homes to. Now by hand gently, you can move your head forwards, and by using the knob underneath the bed, you can level the bed and make sure that it's just barely touching the nozzle. You can move the head by hand to the other side. You can do it again with this screw. Move the whole step backwards. Do it for the rear with the screw on the rear right. And do it to the left again, also leveling it. And now your printer is completely leveled. So that's a trick on how to level your printer without hooking it up to a PC. If you hook it up to a PC and you press home on Z, it will home on Z and it will stay there. But just for the purpose of heating up through the software, the bed is dropping down after homing. For the next point, I want to talk about first layers are essential. Stay with it. As soon as you start printing, keep an eye on your printer for at least the first and second layer. Make sure that the first and second layer is sticking to your bed properly. After the second layer, you can walk away and leave the printer for hours on end to print. But the first layer is crucial. If the first layer doesn't stick properly, your whole print might mess up. For the next slide. Bed adhesion preparation. Removing the print sticker, placing the print sticker, removing the bubbles and degreasing your bed. First is a tip on removing the print sticker. The best thing you can do is make sure that your bed is cold when you remove the print sticker. This way there will be less residue of the glue from the print sticker to your bed. If you pull off the sticker while your bed is hot, more glue will stick to your bed. So make sure that the bed is cold when you pull off the sticker. After that, you want to clean your bed. You can best clean your bed by heating it up to around 40 degrees Celsius. Move the assembly way back. Heat up the bed to 40 degrees Celsius. And use just a regular kitchen cleaner. It's a little abrasive. You put it on there. And while the bed is warm, use a spatula and just rub it. And you will rub off the glue really easy. And after a while, you can just scrape off the glue and any residue, take a cloth and take the residue off. After that, use a simple window wiper. It's glass after all. Use just spray it and clean it with a cloth. And after that, your bed should be completely clean. Make sure your bed is completely clean before you put a print sticker on there, because otherwise, if there's still glue on your bed, you can get a bump. And of course, the first layer, the nozzle can scrape over that bump and cause your whole print to mess up. The easiest way to place a print sticker, I seem to misplace my print sticker, is to first pull the tab on one side and place it on your bed. After that, fold it over and slide it across. That way, you won't get any air bubbles trapped underneath the print sticker. Because again, air bubbles create a bulge, and your nozzle can catch that bulge and tear off your whole print and tear off your print sticker. So make sure there are no air bubbles. If there are any air bubbles, you can just squeeze them to the side. And if you cannot squeeze them to the side, use a small knife and cut them, and that way you can still remove the air underneath the sticker. After that, if the sticker is placed, your print still might not stick to the sticker because of the grease of your hands. By rubbing the sticker and putting it in place, you're rubbing it with your hand. So some of the oil will stick to the sticker, and then your print won't stick to the sticker. So the best thing you can do is get cheap alcohol wipes and very fast, just wipe the grease off. Don't wipe it too long because you will remove the top layer of the sticker. If the top layer is removed, you get a shiny surface and it won't stick as much anymore. So just with an alcohol wipe, just briefly wipe it, and then the grease should be gone and should be ready to print. For the next section, bed adhesion, surface area attached to the print bed. Make sure that your print that you are printing has the largest surface area attached to your print bed. If you have a long, tall object with a small base, it's easy to topple over by the print bed. So make sure that you print a large raft or a large brim to make sure you have a large base on which the print sits. Also, support structures are usually just small little lines. Those small little lines from the support structure don't have a lot of bed adhesion because they only have a small surface. Make sure to put a brim or a raft underneath your support structures to prevent them from messing up halfway during the print. Alternative adhesions. There are a lot of people who are using alternative adhesions for the printer, and that's okay, that's fine. The most common one used is blue painter's tape. You can get it really cheap and you can buy it anywhere. But there's also a small disadvantage on the blue painter's tape. If you put it on and you print on it, works fine. But as soon as you pull off the print, underneath there's always a little bit of tape residue. You always get that little blue fluffy stuff on the bottom, which is really hard to get off. So that's why we use print stickers. Another alternative is hairspray. Some people use hairspray to stick the print to the print bed. That's fine, but the hairspray can get on the rods and into the bearings of your 3D printer, and it can cause damage. So if you're going to use a hairspray, put a box inside it. Make a cardboard box that fits inside and then spray it, so you make sure that there won't be any hairspray on any of the rods or moving parts of the 3D printer. Another famous one is ABS sludge. You can use ABS and make a sludge out of it using nail polish remover or acetone. And you get this sludge, you can smear it on your bed and you can print on that. But for me, I think it's kind of messy. Also, wood glue and glue sticks. Again, those are pretty messy, so I stick to the print stick. For the next slide, please, Frank. How to get the best print results by level of detail. You cannot print any feature smaller than your nozzle size. The nozzle size inside our printer is 0.35 millimeters. Some people want to print jewelry or really tiny objects. Well, it's the same as a milling machine or a lathe. You cannot make anything smaller than the size of your tool. And because we are building up from the ground, you cannot build anything smaller than 0.35 millimeters. In the picture below, you see two words. On the left, you have a cutout into a block, and you can see that the nozzle between the E and the T, the nozzle has to pass between those two letters. So you have to make sure, while designing that there's enough space between those letters for the nozzle to pass through. Otherwise, the software will ignore that path and will not print that path, and then your E and your T will be connected, and you end up with the print you don't want. On the right side, if the letters are protruding upwards from the model, it's laying the base layer, that's going to be fine, and then it's just going to outline the letters, and that is going to work with a 0.35 nozzle. The next slide, please, Frank. Again, I have some tips on details of your 3D print. Layer height. The bigger your model is, the bigger the layer height you can use. Don't try to print really small objects with a layer height of 0.2. Use the smallest layer height you possibly can. If you use larger objects, you can get away with larger layer heights. If you looked at the bunny in the previous slide, that was a 0.2 layer height on a really tiny object. This object is also a 0.2 layer height, and it looks really smooth. That's because it's large. So make sure that the layer height is in proportion with your model. For the next slide, I have some images with common mistakes made while 3D printing. The first one, as I already said, too small of size. People trying to print really, really tiny objects. And as you see in the chairs, they are really tiny self-standing structures. And every time the nozzle will go to one of those legs of the chair and it will melt it. So make sure that the layers are cooling down before it prints again over that layer. And on the second one, it's basically the same as the first one with the cooling. Make sure that every layer has the time to cool down. So lower your print speed and make sure that every layer cools down before you print over it again, because otherwise you will end up something like the middle picture. And on the right picture you see the layer height. This is also a really tiny object with a really large layer height. On the next slide, tolerances and fitting parts together. I also get this question a lot, is that, hey, I print something of around 10 millimeters and I have a hole of around 10 millimeters and they don't fit together. That is because, if you see at the left picture, you can see that the nozzle is pushing the filament down on the layer beneath it. And while pushing it down, it also pushes it outward a little. And if you do that in a circle, what you see on the right side, is that you have a tolerance of 500th of a millimeter. That's really, really small, but on two sides, that will result in 0.1 offset. And if you have that for the hole and also for the part that you want to put in the hole, you have a difference of 0.2 between the two models. So make sure that you account for those offsets. I don't say that it's always 0.2, because if you print at a larger layer height, for instance 0.5 or even larger, 0.3, that diameter can change. So you have to figure out yourself and try and test what the optimal offset is for your part. Orientation. The orientation of your 3D print is crucial when you start printing. You have to find the biggest flat surface to lay on your print bed. And possibly you want to cut your model in two. For instance, I have this model. It's a huge print and I cut it in two parts. And one part was printed like this and the other one was printed like that. And then they were glued together to form one giant part. So sometimes you need to cut up your model to get the best results. And place the overhang towards the back of your printer. The cooling fan is blowing from the back towards the front. So if you have anything that's overhanging, put it towards the back of your printer, so every overlay, every line is being cooled from the rear with the rear fan. Reduce overhang if possible. If you show the slide frame, you can see on the first picture the astronaut is printed upside down, which is really weird, but that will prevent the arms and legs to have overhang. So it's printing upwards. So sometimes you have to think outside of the box on placing your 3D model on your print bed. Next slide, please, Frank. Account for gravity. Any angle up to 45 degrees you can print without support underneath it. Anything over 45 degrees you need to put support underneath. And again, the 45-degree angle, try to put the overhangs as much towards the back of your printer, towards the cooling as possible. And also bridging. The printer will be able to bridge a certain amount of distance. I cannot tell you the distance because that's also dependent on speed, temperature, and also what material you are using. So you have to find the optimal setting for you. If the bridging becomes too large, you can use the support material again underneath your model. For the next slide, I'm going to talk about model structure. Make sure that your 3D model has the following properties. The mesh resolution or polygon count. A circle consists of an infinite number of points. If you would export this, slicing software will have a lot of trouble trying to solve all those little points. So you have to reduce the polygon count as much as you can. But if you lower the resolution too much, you will get those flat edges on a circle that you don't want. Again, there's no standard setting because the larger the circle is, the higher the resolution needs to be. Because if you have a really small circle, those flat edges won't be that as apparent. For me, myself, with the software I usually use an export setting of 0.02 millimeters on any surface or STL. But again, that depends on each software which setting it uses. For the next is avoid infinite small lines, intersecting faces, wrong geometry and holes. The software, the slicing software, needs a complete solid outside of a model. If there are any holes, the software will get confused of what the outside is and what the inside is. So it doesn't know where to place the outline and doesn't know where to place the infill. And that brings me to the next point, because most of the free models on the internet are not that great. People share their knowledge, share their model, but they don't necessarily have the knowledge to export an integral model. So a lot of the models, free models that you can download from the internet, they have holes or they have vertices that are not connected. They have shapes that are, or faces that are inside out with the wrong side. So your software will get confused. If you try to print that, you go like, hey, I see the model, I try to print it, it doesn't print okay. That's because of the model is not completely integral. So make sure that your model is absolutely 100% perfect. For the next slide, check your path after slicing. As soon as you've tried, as soon as you have sliced your model in your slicing software, in the simplified 3D that we use at Leapfrog, you can slice through your model and see how it's going to build up the path. You can see on the left side that if your model is too small and it's going to ignore certain lines, you can already see that in your slicing software. And on the right side, you can see that one is big enough and everything looks okay and you can start printing. The next slide. Play with your printer. Don't be afraid to try to change different settings. You need to get more and more familiar with the following advanced features, and don't be afraid to change those little features, like temperature. You can print PLA at 230 degrees. Everybody says, no, you have to print it at 190, but 230, it will get really, really thin, and sometimes it prints easier, especially at high speeds. So don't be afraid to change the temperature and experiment with that. And also experiment with the extrusion multiplier, because different materials extrude differently. So sometimes you need a little bit more extrusion, and sometimes it's extruding too more and you need a little more, less extrusion. So don't be afraid to increase or reduce the extrusion multiplier. Retraction and extra restart values. Some materials ooze more than others. So sometimes you need to retract more with one certain material than with another material. And also with restart. If you're switching nozzles, if you're printing with two colors, and you're switching from one nozzle to the other, it needs to retract. And after retraction, it wants to print again with that nozzle, it pushes it back. There's this little extra feature called extra restart distance, and you can increase that so the nozzle won't start printing nothing and then will start printing. You want the nozzle to start immediately. So you might want to increase the extra restart distance. And if the extra restart distance is too high, you will get a little blob as soon as it changes color. So don't be afraid to change with that value a little and try to play and see what happens with it. Printing speed. It's always nice to have the highest printing speed as possible, but as soon as you're going to print something with sharp corners, the printer has to stop and start very sudden. So sometimes it's worth to reduce the amount of speed just to get better print results. And for circles, you can increase the print speed. So try different speeds and see what suits your model the best. Cooling values. As I talked earlier, I said give layers the chance to cool down before you print over them again, especially with small objects and with small separate standing structures. So give the layers time to cool down before you print over them, because otherwise you will get really blobby results. And other features you can play with is with infill and support density, and also with outline and parameter shells with wall thicknesses. So don't be afraid to change some of those values. For the next slide, please, Frank. I want to talk about PVA. Printing with PVA is really hard and it's really difficult, and a lot of people have problems with PVA, so that's why I'm giving these small tips for you to get successful prints with PVA. PVA is difficult to print because it has a really very small working range. At 200 degrees it will melt, but at 215 degrees it will already solidify inside your nozzle. So my tip is don't let it sit in your hot end at high temperature. So as soon as you're heating up your nozzles, or if you're printing a model and you're using PVA as a support structure, make sure that the PVA is retracted from your nozzle, because if it sits in your nozzle even at 200 degrees, the temperature will accumulate and it will get hotter and hotter inside, even if your nozzle is only set at 200 degrees, and it will solidify. Nozzle jams are common with PVA. PVA, because it has such a small bandwidth to work within, it's going to happen that it's going to jam. So make sure when you start printing with PVA that you have plenty of spare nozzles and you don't have to wait for that new nozzle to arrive before you can go on with 3D printing. Furthermore, you cannot clean out the PVA by heating it up even more. What you can usually do with PLA or ABS, if it gets stuck in your nozzle, is heat up your nozzle really high to get it out. With PVA, you only make the problem worse. So the only option is, if you get a clog with PVA, is get your nozzle off and use some part of steel guitar string to make your nozzle clean again. And also keep it dry. Keep your PVA dry. It attracts moisture from the air, and PVA that already has moisture in it doesn't print as well as PVA that's absolutely dry. So as soon as you get the PVA, and always store the PVA inside a plastic bag with some silica gel, and don't store it in any wet space. If your PVA is exposed to moisture or in outside air, put it in an oven and bake out the excess water. For more tips on PVA printing, you can find it on the Leapfrog support website, and all these points are also on the website. And before you start with printing with PVA, consider the alternatives. Because it's such a difficult material to print with, try to look for alternatives. There's, for instance, HIPS. You can use, if you're printing with ABS, you can use ABS material. If you're printing with PLA, you can use PLA material as support structure. Only use PVA if you don't have any other option, and the only option is to use PVA. For the next slide, we're going to nylon. At Leapfrog we have nylon, but also nylon is really hard to print. So I'm giving you tips on the next slide on printing with nylon. It is on one hand easy to print because it extrudes nicely, it doesn't clog as much, but it warps. It warps really bad. It warps even worse than ABS. So make sure that you follow the following tips and you should be able to get some nice prints with nylon. First of all is print at high temperatures. The temperature of the nozzle is around 240 degrees. And also you can use the Leapfrog dust cover that we recently brought out, and it will be available soon on the website, that you can trap the heat inside your printer while printing to reduce the warping. Use a very hot bed between 70 or 80 degrees, and do not turn off the bed while printing. A lot of prints print with, for instance, PLA, you can start the first layers with 40 degrees, and after layer 5 or layer 10 you can switch off the bed and keep on printing with a cool bed. With nylon, keep the bed at 70 or 80 degrees and do not switch it off, because otherwise it will warp off your bed. Nylon will warp off your bed even with print sticker. It will just tear the print sticker off your bed. So use an insanely large brim or raft on your model. The larger the brim and the larger the raft you print, the less likely your model itself will warp. And usually a brim is only one line thick, but for nylon I advise use 2 or 3 or 4 layers thick of brim to make sure that your model stays flat and doesn't warp off your bed. And also, nylon is really susceptible to water, so keep it dry. It absorbs more than 10% of its own weight in water within 24 hours. So it just sucks it up from the air. So keep it inside a plastic bag with silica gel and keep it away from moisture, because once the moisture is in the nylon, it's really hard to print, if not even at all printable anymore. If there's moisture inside your nylon, you can put it in an oven and bake it out. And do not cool. That's the final point on the sheet. Do not cool. Keep the cooling fan off. Even with overhang, nylon warps a lot because it cools down so fast. So you don't really need that cooling fan. So make sure that the cooling fan during your whole print is off, because otherwise, if you use the cooling fan, you can get more warpage. Well, finally, for the next slide, Frank, we see pimping your model. For visual representations, a 3D print does not have to mean a final product. You can use spray filler, you can sand it, or use a Dremel tool to get the final result and get a better finish on your model. As you can see on the slide on the bottom pictures, on the left side you see one that is not treated, and on the right side one that is spray filled, painted, and it looks a lot nicer. You can use lacquer, model kit paint, water-based paint, you can use clear coat, and you can find your own exciting finishes. I recently saw, as you see on the right picture, someone on 3D Hubs used model train flocking on his model, and it gave an insanely nice finish and a really exciting finish. So it's up to you to find a new finish on your 3D model. And finally, there is no final solution. If someone tells me, please tell me how to perfectly 3D print, well, there is no final solution, because every material prints differently. Not only ABS, PLA, nylon, PVA, or any material, but also two rolls of the same material with different colors. Black can print a lot different than white. So you have to might adjust your extrusion multiplier or your temperature setting only based on color. So I cannot tell you this is absolutely 100% accurate. You have to play with it yourself. And every model prints different, because everything is up to your model. It depends on wall thickness, infill percentage, orientation, overhang, and all sorts of dynamics that happens to your model. So in the end, it's all up to you. Get to know your printer, get to know your machine, and get to know your materials, and happy printing. I guess you, Frank.
Well, David, thank you very much for your presentation. Also, thank you for staying with us the whole time. We saw many viewers on our channel. Last thing I wanted to say, also on Twitter, by the way, and thank you also for chatting. We saw some active chats going on there. Yeah, last thing I want to say to you as well, that if you got interested in the HS and you might have created a 2014 model now, we want to help you with the purchase of an HS with a 10% discount. David is showing the slide right now, so you can use the coupon code printers10, which will give you a 10% discount on the printers. If you think, well, I'm ready to start printing with PVA or with nylon, to experiment with these kind of materials, we will help you with a 17% discount. You can use the coupon code filament17. Now those coupon codes you can insert on our web shop, www.lpfrg.com, and go to store. The coupon codes will be valid for 1 week. Now, as for the webinar, we're intended to give these webinars more frequently. So the next webinar will be we will have the next webinar the 30th of April, and this will be a webinar with a focus on engineers that want to start with 3D printing. We will cover the basics of 3D printing. Also, we did research among some large engineering companies such as Airbus and such as Philips. And we conducted research how they use 3D desktop printers in the working processes. And I'm going to show some live cases during these webinars. So if you're interested in joining, or if you know some family, friends, or colleagues that want to join, just send an email to sales@lpfrg.com, and we will subscribe you for the webinar of the 30th of April. This so far was our webinar. Thank you all for watching, and we hope to see you next time. Bye-bye.